There we go. There she is. Well, we're making progress. Okay, so let us go to launch meeting. Oh, you want to see something? Yeah, I got a couple of things to show you. Well, not that, not that, not that, not this, not that. Well, I'll show you that later. What was I going to show you? This guy. Check it. This guy was high school athlete. This was his senior year, right? You know, in the state of California, there's no football season. So this guy was, of course, planning on getting some scholarships. He was 2019 Defensive Lineman of the Year. And he just sent this tweet: 0 offers, 0 looks, 0 commitments, 0 time on campus, 0 homecoming, 0 prom, 0 traditional graduation. What a wasted final year of school. Worked hard and dedicated for absolutely 0. Big shout out to Gavin Newsom. You got what you wanted.
So there's 1.5 million signatures already.
Yeah. Well, I think,
almost. Yeah, 1.4, I think. And you need
1.5,
but they're going to try to get 1.8 just to be safe.
Yeah. Now, I heard, I'll bet you, this is my prophecy just because I'm cynical and old, but I think that about a month before they have the recall election, he's going to open up the schools and hope that everyone is going to forget why they hate him so much.
No, people are determined.
Unfortunately, people will forget. California seems to do that very well.
It's the weather, you know, it's the weather's
Yeah,
nice.
ridiculous. I'm trying to ignore it because I think people forget too much.
Yeah, it'll just anger you. Well, the thing is, with all these lockdowns and stuff, I think that people are just going to go the next opportunity they have. They're just going to reelect all the people that put them in this place. So, incidentally, I saw, I was talking to someone who told me that she had, in a small house, 1,500 square foot house, she had the outdoor service replaced and the indoor service panel replaced, and they charged her $9 grand. $9 grand, 2-day job. Pretty easy job too. $9 grand, skilled trades. All right, so let's go to login because this is pro demand. I think, yeah, I don't know why I didn't get no new students this semester. I'm very curious about that. So let's go. Mr. Burks, what year is your vehicle?
2005.
2005, yes.
Ford.
Ford what? 150?
F-250 Super Duty.
F-250 Super Duty. Why is it not here?
What's wrong?
Pickup, I guess. Yeah, there we go. Which engine?
6.8.
6.8? Ooh la la. F-250 Super Duty, that's the one. Okay, extra cab?
Crew cab.
Yeah, how come you got a nicer truck than I got? 4-wheel drive, rear-wheel drive?
Rear.
Okay. Automatic trans?
Yes.
Okay. And use this vehicle. There we go. All right, so let us go to front brakes. Right there. And what do we want to look at? Top repairs? Nah. Remove and replace? How about that? Well, component operation. Let's try that. Front disc brake system right there. Okay. They're going to give me any drawings? What in the world? It's too hard. All right. So we'll get out of component operation because it's not as much fun as I thought it would be. Remove and replace, OEM testing specifications after repair. How about real fixes? No, specifications. There we go. Now I got this stupid Zoom thing in the way. Oh man, we got students coming in. Sorry. Well, all it wants to tell you is bleeding, general specifications. Well, let's see. That's a good one right there. So it's going to give you brake pad thickness, 3 millimeters. That's it. Okay. Front disc minimum thickness, rear disc minimum thickness. Oh, it's got 4-wheel disc. Okay. And tells you what lubricant to use. And get out of here. Hey, Gabe. Go to testing. Well, come on now. Yeah, nice. It looks like I drew that. The hell. Road test, brake disc. Let's see. Remove the brake disc right there. That's what we want to see. There is the hub right there. There's the rotor right there. There's another hub. Yeah, I guess. Okay. Hub extender, I guess they call it. Okay, that's the only one on that page. Removal. Okay, remove and discard the 2 caliper anchor plate bolts. You're supposed to put in new ones. Oh, those are torque to yield, huh? Are they? Marking wheel stud and corresponding brake disc stud hole. This helps to make sure the lowest front brake disc runout is maintained during reassembly. Did you do that?
No.
Ah, okay. Well, that's for dual rear.
That looks like a 4-wheel drive. There's a locking hub on there.
Yeah, that's the front. Says single rear wheel vehicles.
Hmm.
Yeah, that is the front, the 4-wheel drives. That is the front, but let's see. They're talking about run out though, so yeah, don't say anything about it. Okay, let's see. Front brake disc caliper, 2 new bolts. Yeah, it's supposed to be 2 new bolts. Tightened to 166 foot-pounds. Boy, yeah, I'm not sure. You better have a good breaker bar if you put Loctite on those and you want to get them apart again. So let us go back here to there. Where are we at? Testing. Road test, brake pads. Brake disc, front disc brakes. We already talked about those. Brake caliper guide pins. Non-pressure leaks. Master cylinders, parking brake, adjustable pedals, symptom charts. Brake lockup. No, that's not it. Brakes drag. Well, that can't be parking brake because that wouldn't be on the front. Guide pins. Yeah. Brakes drag is what I'm thinking. Disc brake caliper. Repair or install. You know. Okay. You know what? Now that I think about it, Chuck, what about this? Did you take the cap off the master brake cylinder when you pushed the piston back?
Yes.
Oh, you did. Because I was thinking if you didn't take the cap off and you push the piston back, it might pressurize and push the piston to apply. Okay.
That often the day depression, yeah.
Okay. No, I'm the master cylinder cap, not the bleeder valve cap.
Mhm.
Okay.
Yeah.
Okay. Carry out the brake booster component test. Carry out the brake master cylinder component test. I would not go too far down that road because why would doing brakes on one side all of a sudden cause master cylinder failure? Okay, let's see. Shows you all this different. Yeah, I mean, ProDemand is 90. We can all agree that ProDemand is 90 billion times better than Chilton's, because one of the problems with Chilton's is that they don't convert all their drawings and specifications and text into the same format. So it's like you got to learn every different model and make manufacturer. You got to learn a new language. But can't have everything, folks. So I'm going to log out. Anyway, our good friend Chuck discovered that was working again. So I wanted you to share in our joy.
Same password and everything?
Say what?
Oh, yeah? Okay.
Yeah. So we're back in business, which is groovy.
Thanks.
Incidentally, we were talking about electric motors. Incidentally, that's how big, let me see that. Sorry, let's do it again. Yeah, that's how big a generator is for a hospital, and they got 2 of them. And you can see that the generator itself is about 8 feet long and about 4 feet in diameter. It's being run by a V16 Caterpillar motor, which probably that's probably the one they put in a locomotive. In fact, this is probably the exact same power unit out of a locomotive. It looks to be the right size. And the funny thing is, if you look over here, Control plus. That didn't work. Let's try this. Control plus. No, still didn't work. The point I was trying to make was, if you look over here, you can see that there's a wall of about 12 foot by 12 foot radiator with 4 3-foot in diameter fans. I'm sorry, 4 3-foot in diameter fans. This is the program they teach at Citrus College. If you know any young people that really need to get a life, that's a good life. And I was really happy because today one of my students said, "Oh yeah," started asking about registering at Citrus. I'm like, "You mean you already been accepted?" He's like, "Yeah." I mean, you fill out the application. The same application for one community college goes for all of them. So, it's really, really simple, and it's not that complicated. And the happy and sad part about this time of year for me is that we begin to see the young people that are going to sink and the young people that are going to swim, and bittersweet, Okay, well, we're talking about electromagnetism. Doggone it. We're talking about electromagnetism. Welcome, everybody. Where is everybody?
I'm here.
Yeah, I'm here. Right, exactly. Okay. Monday's a holiday, and so is the Monday after that. Oh, I didn't tell you, staff meeting. So it turns out that our graduation rate, that's usually 92% for seniors, is projected to be 80%. And that's after all the remediations, we cut down the amount of instruction from 30 hours a week to 10 and gave Mondays off. And we're allowing them to remediate last semester and blah, blah, blah. Counselors have been bending over backwards. And yeah, 170 students look like they're going to be empty chairs, which ain't the worst news. The worst news is the 9th graders, 50% of them are projected to not graduate high school. Right?
How are the schools handling that? Are they going to make them retake 9th grade?
Poorly, very poorly. Yeah, they would have to, right? Well, I mean, who knows? Because
I'm asking only because it seems like these last years, just being around, that they pass everyone, no one fails. So I'm just curious how that's going to work.
Right? Yeah, I know. So, I mean, I never thought we would call 41% a D, but we're doing it.
Oh,
So,
really? Is that
right.
low?
Yeah, this is the kind of people you want, fixing your food, fixing your car,
God.
Yeah.
doing open heart surgery. So, yeah. So, I think there's going to be ramifications for this for maybe generations, but definitely at least 10 years. Because the little kids, all the little kids that were supposed to learn to read this year.
I can't even imagine being a parent of an elementary school age student.
Yeah. Imagine if your kid had special needs. It's just disastrous. And all the athletes that were trying to get scholarships, and we didn't have any athletic seasons. Now, I must say, okay, so the principal said that if it gets within a month of the end of school and they say we can open up the schools, they're not going to open up the schools at that point. But
yeah, why would they?
I suspect they're probably going to open up the schools. I think the political pressure is overwhelming, and there's too many politicians that can put this as a W if they open up the schools. Now, we see that the statistics tell us that there's been no difference between the places where they opened up the schools and the places they didn't. But I think there's a lot of politicians that are going to say, well, I'm the one that opened up the schools. I'm the friend of the working man. So that's whatever. I mean, it gets the schools open. I just wonder if we're going to triple mask, quadruple mask. I saw a meme where they had the whole box of masks on their face, and was like, wow. So anyways, my point was, let's get to work.
Okay.
We have been talking about electromagnetism, and we got through pretty much the whole thing. Talked about half-wave rectifiers, talked about full-wave rectification. And because what we're trying to do when it comes to rectification is we're trying to turn alternating current into direct current so that we can charge batteries. Okay. So now, since we're done with the real theoretical part of the class, which electromagnetism you have to address as a theoretical, because there's no way you can figure it out by working. It's just impossible. I mean, you have to understand the relationship between current and magnetic fields, and that you can't learn that by looking at it. So here's what I want to do. I want to talk to you about this basic arrangement. So I'm going to draw this. All these teeth are supposed to be the same size, except they're supposed to be a big divot like that. So this is a circle of sorts. And this you're going to see all over the place. And if you're not seeing it all over the place yet, you will. And just goes like this. Now, what we had studied before is a rotating bar magnet like that. But this is a little more sophisticated because instead of having one or two teeth, now this is going to have like what, 58 teeth in the case of the LS motor crankshafts. Why? Because it's going to give us more precise control, more precise detection. So this is called a trigger wheel, and it's called a trigger wheel because a trigger starts a process. And this is still a pickup coil. There you go. Now, it would have been nice if I'd done a better job of drawing that wheel. Would have. Let me show you what it looks like in real life. There you go. See that right there?
Yeah.
This is a crankshaft, this evening, y'all. This is a crankshaft. Man, there's a lot of resources there's a lot of resources on YouTube that are in Spanish, diagnostic resources that are in Spanish. I was blown away. In fact, there were better resources available in Spanish on some things than there were in English. Okay, on the back of this crankshaft, there is the trigger wheel. It's hard to see back here. It's a little easier to see right there, but it's much easier to see right here. And as I say, this one has 58 teeth. The prior one, the 2005, I think it was, had 24 teeth. 2006, the later, has 58 teeth. Why? Because, well, it's like the difference between a comb that's got spread apart tines and one that has closer tines. It allows you to do finer work. And I don't know why I know that the little things that stick out of forks are called tines, but I mean, that stick out of combs are called tines, but must have read a lot when I was a kid. Must have had an unhappy childhood. That was a joke. The point I was trying to make was, now they call this a reluctor wheel. You'll often see them called a tone ring. I mean, they have a bunch of different names. But I call them trigger wheels just because that's the most common thing you're likely to see them called. And it has a couple of important uses, but the most important for our application is this setup is ubiquitous. Can you tell I went to college? This setup is commonly used for speed sensors, speed and position sensors, I should say. Hey, Chuck, how much are you going to charge me to change the radiator in that stupid Suburban? I've got the radiator. I got the coolant.
You could do a little borrowing.
Ooh, what do I got that you want? Ooh, power probe.
That probe.
Ooh, the power probe.
Yeah.
Yeah. Problem is, if I brought it over to your house, then I would need to write it back. Or, yeah, shoot. Okay, yeah, let's think about that. Yeah, I just realized like 2 days ago that I didn't get the power probe 4 yet.
Mhm.
All right, so this setup is commonly used for speed and position sensors, and it's used all over the car. So that's what we want to study tonight, because it gives us an opportunity to take our theory and see where and how it's applied. So let's do that. Well, the first place we want to look is what's called the CKP. That's the crankshaft position sensor. And you say, well, that just tells us crankshaft position. No, it does a lot more than that. And crankshaft position sensor is one of the most important sensors there is. In fact, if it's not working, your engine will not start. Because what does the crankshaft position sensor do? Well, it tells us where in the crankshaft rotation the crankshaft actually is, which as a result tells us where each one of the pistons is, right? Because the crankshaft is connected to the connecting rod. The connecting rods are connected to the pistons. That's the crankshaft, in case anybody forgot. That's the crankshaft right there. Well, that's the crankshaft right there too. Yeah, see? And there's 2 pistons hanging off of this one, 2 connecting rods connected here, 2 connecting rods connected here, 2 connected there, 2 connected there. It's V8 engine. So if we know where this crankshaft is in its rotation, for instance, we know where the number 1 piston is in its travels. So how do we know that? Well, you see this notch right here? This notch lines up with the pickup coil when the number 1 piston is at the top of its travel, top dead center. From there, we can calculate where every other piston is, because remember, they go up in pairs, right? So if you have a 4-cylinder engine, 2 of the pistons are going to be at the top of the travel, while the other 2 pistons are at the bottom of their travel. They have this thing called companion cylinders. In a V8 engine, well, in a Chevrolet V8 engine, number 1 and number 6 are both going to be at the top. The pistons are both going to be at the top of the travel at the same time. They're not going to be on the same stroke, or I should say between the same strokes, but they're both going to be at top dead center. See, the number 1 piston is going to be at top dead center between the compression and the power stroke, but the number 6 cylinder is going to be at top dead center between the exhaust and the intake stroke. See, because they're 360 degrees out from each other. So what does that mean? Well, depends if we're going on crankshaft degrees or camshaft degrees, be 180 degrees out. Whatever the case, both of those pistons are up at the same time. They're just on different strokes. Now, if I have a 4-cylinder engine, let's do it a 4-cylinder engine because it's easier to understand. I'm going to have 2 pistons up when I have 2 pistons down. But all 4 pistons are going to be on different strokes. One's going to be on intake, one's going to be on compression, one's going to be on power, and one's going to be on exhaust. That's how we get a smooth running engine. Because if we had 2 pistons on the power stroke at the same time, that would be a whole lot of power fed to the crankshaft, and it would make the engine run very rough. Unless I had a V16, which I guess is always going to have, well, never mind. I don't want to go down that road, but I could. My point was, we want to space out the power impulses so that the engine runs more smoothly. Now, one of the reasons that an 8-cylinder engine always runs more smoothly than a 4-cylinder engine is that a 4-cylinder engine has a power impulse every 90 degrees, whereas a V8, has one every 180 degrees, where crankshaft degrees, whereas a 8-cylinder engine has one every 90 degrees. So as a result, it's much smoother. Instead of going ba-dum, 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 it goes brum, brum. There's less time between the firing impulses, and as a result, it runs more smoothly. Okay, So the crankshaft position sensor is a sensor. It's usually on the front cover, except on the LS's, it's on the back. You have to take the starter out to take it out on the back of the crankshaft. And what it's going to do is it's going to tell the PCM, ECU, ECM, whatever you want to call it, powertrain control module, electronic control module, electronic control unit, whatever you want to call it. It's going to report to the powertrain computer, one, where the crankshaft is in its rotation, which is going to tell us where the pistons are in their travels. And it's also going to tell us whether the crankshaft is turning or not, and if so, how fast. So it's used as both a speed and a position sensor. Okay, so let's see how that works out. Well, we know that it's going to create a alternating current output. And we also know that each time one of these teeth passes, because it's made of steel, it's ferrous. I saw the most amazing video today where a guy was actually demonstrating how a pickup coil worked, and he actually put a knife in a salad spinner, and he started zapping the little salad spinner, and the knife would come by the pickup coil, and it actually worked. I'm like, I was stunned. I'd never seen such a thing. I was pretty amazed. Every once in a while, I get pretty amazed, but every once in a while. We know that it's going to create an AC signal, a sine wave. And we know that the sine wave is going to have a length proportional to how fast it's spinning. For instance, if I have a slow rotation, it could look like this: positive voltage, negative voltage, zero voltage. If however, I have a fast rotation, it could go like this. So that's a measure of frequency. From here to here is called a cycle. Just a little review. From here to here is called a cycle because the waveform starts over again. So it's like any other cycle: spring, summer, fall, winter, spring, summer, fall, winter. Cycle just refers to how long it takes before it repeats itself. Intake, compression, power, exhaust. Intake, compression, power, exhaust. Well, as you can see in this drawing, one cycle goes from here to there. Takes up this much time. Well, over here, it only takes this much time. Which means there is a higher frequency. Now, I demonstrated that for you before. Just to make sure we're on the same page, I want to make sure and do it again, I think. Here's my oscilloscope. An oscilloscope displays voltage over time. Waveform viewer, yes. Just like the cheap scan tools. Low frequency pulse generators, yes. I'm going to come here and I change what's highlighted. Yes, that's what I want to change. I come down to 0.5 volts positive. I'm going to come down here. Yes, that's what I want to change. I want to change it to negative 0.5 volts. And we see that I'm starting to pick up the induced voltage from what I think is from the computer power supply. Because every time the fan goes on, the waveform gets bigger. Okay, so now I'm going to come over here. Evidently, I didn't get it where I need it. There we go. Now, right here, it says 50 milliseconds. Now, we can see that I'm basically getting 3 wavelengths in 50 milliseconds. Well, there's 1,000 milliseconds in a second. So there's 20 of these time segments in a second. Well, if I take 3 and I multiply it by 20, that's 60. This is 60 cycle single phase alternating current. Now, if I go like this, the voltage goes away because voltage refers to the difference between one place and another. If I go like this, or if I go like that, basically I'm making an antenna of these leads, and the induced voltage affects the circuit differently. So here's what I'm going to do. I have my beautiful, used to be a fan, used to be a table fan. I took the propeller off. So I've got my cordless drill hooked up to the shaft that has a rotating magnet on it. There's a bunch of field coils around surrounding the magnet. So now what I'm going to do is I'm going to take this end right there, and I'm going to put one lead on one end. Hey, Gabe, how much do you charge to replace 2 services in a 1,500 square foot house?
2 services?
Yeah, the outdoor and the indoor.
Also, the indoor has like a little sub panel.
Yeah.
Had to look at it.
$9 grand?
No, less than that.
Yeah, I know. This
Way
first
less
time.
than that. Way
Yeah, I
less
know.
than that.
I know.
9
right?
grand. That's whoa.
They got freaking took so hard.
A
That's what
service should cost tops probably like 2 grand.
Yeah. They got took so hard.
Because the material itself is probably about a G, you know,
Right.
or a little over a G. You know, the most expensive part is the wire, and it's only like what, you only need like 10 feet or something like that, maybe a little
Right.
bit over. 9 grand.
Yeah.
Hey, show me these customers.
Right? Yeah. Yeah. They got took.
Whoa,
And it took them
that's
2 days.
and for a little sub panel, like in the garage or whatever, too.
$7 grand, 2 days. Yeah. Skilled trades. It's all about the skilled trades, man.
What?
Yep. Well, that's what happens when you don't take Rookos class. All right. So what I'm going to do is I'm going to come over here and I'm going to put this to 200 milliseconds for the time instead of 50, because the waveform turns out better. So I go to 200 milliseconds. That means there's 5 of these in 1 second. So I'm going to start rotating the magnet. And you see as I rotate the magnet that it starts to generate alternating current, because rotating magnets in the presence of coils creates alternating current. So I do it slowly. Now, as I speed up, let me go slow. And you can see I can get about 1 wavelength, maybe 1.5 wavelengths in 1/5 of a second. Well, if I speed it up, you can see I get more and more wavelengths in the same amount of time. And you see if I go maximum speed that I get probably what, 7 wavelengths in 1/5 of a second. So this is what a speed sensor does, is it displays frequencies and reports those to a computer to do something about it. Just to make sure you make sure. Okay, so this trigger wheel is going to be mounted on the crankshaft. Could be in the middle, could be in the back, could be in the front, really. And the pickup coil is going to be bolted to the engine block, usually. Okay. And the frequency is going to be proportional to how fast the crankshaft is spinning. Now, here's the important thing. See this notch right here? That's what allows us to know the crankshaft position. And that's important because that's what tells us where the pistons are. And if you don't know where the pistons are, then you won't know when to fire the fuel injectors or the spark plugs. So that's a big deal. Now you say, yeah, but it only tells you the position of one piston. Well, that's all I need, because if I know the position of one piston, I can calculate the position of all the rest, or I could just look at it, take a picture, make a drawing, whatever. So let me show you what this wavelength looks like. Come over here like this, come over there. 9 grand cash. No, wait, do you have to pull a permit for that? Allegedly?
Well, yeah, allegedly, but most times
Uh-huh.
it's not done.
Yeah, you know why? Because you would have to put AFCIs, right?
Mm-hmm.
Uh-huh. I'll bet you that didn't get done.
That's crazy. 9 grand. That's crazy.
With no permit, yeah. And
With
no
no permit?
And no AFCIs, yeah. Okay, so this is what it is. This is 4 wavelengths, four patterns. The top one in blue is the crankshaft position sensor. And where the notch is where this big dip in the signal is. So you're going to see 58 of these. These are actually AC waveforms. They're just cropped off on the top. They're actually AC waveforms, but this big wide part is where the notch is. That's how the computer knows this is where the #1 piston is at top dead center, at the top of its travel. Ready, Chuck? Here we go. The red one is one of the camshafts position sensors. The green one is one of the other camshaft position sensors, right? So one of these is intake, one of these is exhaust. Camshaft position sensors, which is the exact same mechanism, it's just on the camshaft instead of the crankshaft, and we'll talk about why that's important in a moment. And what's this, Chuck? Is that the ignition or is that the fuel injector firing?
Pretty long pulse. I'd have to say spark.
Yeah. Yeah, because if we go like this, we can see that it happens every once in a while. The camshaft position sensor is going like this. We can see, now this is interesting, Chuck, because it's got variable valve timing. So we can see that the camshaft and the crankshaft and the other camshaft are not synchronized because variable valve timing's doing all this with all the camshafts. That's why diag.net. Where's Michelle? This is like the first class she's ever missed, ever. Did she forget that eaten by a rat? Yeah, and then you can see the spark plugs firing. Yeah.
Yeah,
Yeah.
I was just thinking of texting her.
Yeah, you should. Give her some crap. Where's Reddy?
Yeah, I will.
Okay, so the weird thing is, if you go to this, then you can walk your way through the whole system. I mean, through a series. But that's what it looks like, folks. And what we're doing here, see, because there's all these different cars, all these different manufacturers, all these different models, all these different engines. And what people are doing on diag.net, which if you're not there, you should be, premier diagnostic website in the world and maybe the universe. What they're doing is they're reviewing waveforms to say, okay, is this working correctly, or do I have did I skip a tooth on my timing belt, or there's no way of knowing, because when variable valve timing is like this, is like, who knows where it's supposed to look, what it's supposed to look like. So this is what they call a known good waveform, where this is a waveform analysis somebody did on an engine that was running correctly. So this is what it's supposed to look like. This is at idle speed, for instance. Anyway, I wanted to show you what the crankshaft position sensor signal looked like, so it wouldn't just be some theoretical thing to you. Okay, so we can see that this allows the computer to know where #1 top dead center is, and thus we know the position of every other piston just through calculations. It's a matter of engine design and construction. All right, so let's go here. New share. There we go. Okay. Now, here's the thing about crankshaft position sensor. Not only does it tell us the speed of the crankshaft and position, remember the fuel pump, as soon as you put the key in and turn the ignition on, the PCM is going to turn the fuel pump on for 2 seconds. Why? To pressurize the system. Then it's going to shut the fuel pump off. And it's not going to turn the fuel pump back on until the PCM sees crankshaft rotation. Well, how does the PCM see crankshaft rotation? It's coming out of the crankshaft position sensor. This is also where you get your RPM signal. So back in the olden days, back in the bad old days, even the best scan tools, you had to break out the oscilloscope and start back probing and to find out whether this thing was putting out a good signal. Now, even the cheapest scan tools, you know, this little rascal, even the cheapest scan tools will give you a graph of CKP output. So we're making amazing strides. Really, the things are so much better than they used to be. Love it, love it. Plus, what we're going to see is that the people who know how to do this are going to keep increasing their salaries, because this is just stuff. It's stuff people can't do unless you've had some training, you know. Yeah, I think I told you about this, Chuck. The problem that people are having with Identifix is people that don't know how to fix cars. All they're doing is they're looking at the number one thing that fixed the car. I mean, ProDemand has this too. They're looking at the number one thing that fixed the car, the highest probability, and they're just replacing that. It's terrible. Can you imagine the destruction that's going on in people's lives, you know, as you're buying these $600 parts, no return? Okay. Those two things about the crankshaft position sensor are cool, but really, to me, the coolest thing about the crankshaft position sensor is understanding that when I look at the tachometer, which is telling us engine revolutions per minute, and it says 650 RPM, that's only an average, because this crankshaft is continuously speeding up and slowing down. In actuality, it's continuously speeding up and slowing down. Why? Because when I pull the piston down on the intake stroke, it's pulling through a restriction. That's going to slow the crankshaft down. When I close the intake valve and I try to squeeze all of this air and fuel into this much space, that's going to really slow the crankshaft down. Spark plug fires, boom, power stroke, huge amount of force pushing the top of the piston, which is going to speed up the crankshaft. And then when I open up the exhaust valve and I push the smoke out, it's going to slow the crankshaft down again. So when it says 650 RPM, that's just an average. What we're actually seeing, and this 58 tooth trigger wheel is going to demonstrate for us, is that that crankshaft is continuously, well, through the 4 strokes, intake, compression, power, exhaust, it would be slow, slower, faster, slow, slow, slower, faster, slow, as long as that cylinder is operating correctly. But what if we have a misfire? What's a misfire? A misfire is when combustion either doesn't happen or it doesn't happen correctly. Let's say it doesn't happen, just to make the easy case. Now it's going to go slow, slower, but there isn't going to be anything to push the piston down, so there's not going to be anything to speed up the crankshaft. So it's going to go slow, slower, slow, 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 slower, slow, slow. And the PCM says, you know what? We didn't get combustion. And it knows which cylinder because of the notch. Tell me that's not freaking cool. So we can do misfire detection with this. And that's the coolest thing about it to me, because what it enables us to do is, you know, if I have a high speed, let's say I have a high speed misfire, only happens at 6,000 RPM. You would never, ever in a million years be able to find that any other way. But since this thing is putting out, you know, what's 58 times 6,000? 58 times 6,000 is what, 300,000 pulses per minute? You would never be able to figure that out. But if you had a high-speed misfire, it'll show up and it'll turn on your check engine light. Tell you got a misfire, cylinder number 7. Tell me that's not cool. Or slow, slower, fast, slow, slow, slower, fast, slow. Let's say you got poor combustion, because maybe you got a clogged fuel injector that's only partially clogged. It's going to go slow, slower, fast, but it's not going to go as fast as it should. And the computer can pick up that pattern and say, you know what? You've got a misfire, even without the cylinder being completely dead. It can say, you know what? You got a misfire. Your power balance test would come out wrong. What's a power balance test? Power balance test says we're going to test the contribution of each cylinder. Back in the olden days, back when I was Chuck's age, we used to have to take the engine apart. It was a drag. We used to have to disconnect the spark plug wire or something like that. It was a drag. But now we can do it with a scan tool. And the engine can do it. I mean, basically the computer can do it automatically. So this is a million times better. The misfire detection is a million times better because it's going to fire. Like I said, if you got a high-speed misfire, which is not uncommon, if you got a high-speed misfire, there's no way in a million years you'd find it any other way. Now, right now, the racers, they're still using small block Chevys and carburetors and distributors. But eventually, you know, you're going to understand, well, what was the highest performance 427 back in 1969? 435 horse? Well, mine puts out 505, and from what Scott Brown tells me, it could easily put out almost 100 more than that. Well, let's say 80 at least, just with reprogramming. Okay, how does that happen? Well, because you got more precise fuel and spark control. Yeah, especially with cams. So why are these modern engines so much more efficient? Because it just enables us to have much more precise control, and that's misfire detection, crankshaft position sensor. So I'm going to write plus misfire detection. Gabe, I was so worried you were never going to come back. I thought I needed a Tic Tac or something. There you go. All right, CMP. Now you say, well, crankshaft position sensor, why don't you just call it a CPS? Because camshaft position sensor would be the same thing. So instead we said crank position. This one is cam position. Now we used to have one camshaft position sensor, and it's an important sensor because, well, let me finish the sentence. We used to have one camshaft position sensor, but now that we have variable valve timing on almost every engine, now we're going to have two, one on each camshaft. And it's an important sensor for this reason. Watch my hand. This is the piston. This is the bottom of the connecting rod. So that's going to be attached to the crankshaft. Intake, compression, power, exhaust. How many times did the crankshaft spin? Twice. Watch. Intake, down, compression, up, power, down, exhaust, up. Crankshaft spun twice. So even if I know that the number one piston is on top dead center, I don't know which top dead center it is. It could be the top dead center between the exhaust stroke and the intake stroke, but it could be the top dead center between the compression stroke and the power stroke. In order to find out where in the four-stroke cycle I am, I have to know where the camshaft is. Remember, the crankshaft spins twice in every four-stroke cycle, but the camshaft only spins once. That's why the camshaft sprocket or pulley is half the size of the crankshaft one. Okay, now the camshaft knows where in the four-stroke cycle we are because it's spinning at half the speed. So the camshaft position sensor, let's see. Camshaft position sensor. It's located on the camshaft, just like the crankshaft. But what it does is it tells us we don't really care about the speed because we know the speed's going to be it's going to be half as fast as the crankshaft, so we don't really care about the speed. What we care about is the position. Tells us where in the four-stroke cycle we are on the number one cylinder. Now, if we know where we are in the number one cylinder, we know where we are in every other cylinder as well, right? Because it's just a matter of engine design construction. I mean, you could look with your own eyes and just write it down where you'd be. It's all a matter of crankshaft degrees. Okay, so the camshaft position sensor is there to tell us where in the 4-stroke cycle our number one cylinder is. And by knowing that, we can tell about the same thing about every other cylinder, because it's mathematical at that point. Well, that's what the camshaft position sensor used to be used for, but now it's used for something really, really sophisticated. And that is VVT. And VVT stands for variable valve timing. Oh, did you hear that Bank of America looked at all the consumer records of people that were in Washington, D.C. on the 6th, and they turned them over to the feds?
Really?
Yes.
What do they call it when corporations and government form like a fascia, you know?
Collusion.
What do you call that? You know, a fascia? Yeah, anyway, fascia is a band of 6. The
Yeah.
point I was trying to make was, yeah, I wonder why they want to go to a cashless society.
No. No, man.
I wonder. The point I
Yeah.
was trying to make was variable valve timing. What is it?
It's gonna be so bad.
Well, back in the olden days, we had this thing called VTEC. Honda came up with VTEC. And what VTEC did was, if you were under, it's the problem it was that the camshaft provides the personality for the engine. And you can have a camshaft. Remember, what does the camshaft do? It controls the valve.
Mm-hmm.
So it determines how far it opens and how long it stays open. That determines the personality of the engine. Now, back in the olden days, it used to be that if you had an engine that ran really well at high RPMs, it ran like total hell at lower RPMs. And if it ran well at low RPMs, it didn't have much power up top, because the camshaft determined the personality of the engine, and you couldn't have it both ways. So VTEC came out from the Honda Corporation, and what they did was they had a mechanism on the camshaft that was really sophisticated, because what it did was it gave you one cam profile at low RPMs, but then at 3,500 RPM, the computer opened up a solenoid that allowed oil flow to come in, and what it did was it got that valve to open further and stay open longer, which gave you a ton more fuel. As a result, the engine acted like a small camshaft at low RPMs, giving you good fuel economy, good drivability, good emissions. And then when you got it above 3,500, it started acting like a race motor. In fact, for all intents and purposes, it was. You want to know what the number one cause of failure is on a VTEC system? It's because people don't change the oil, and the screen to that solenoid gets clogged up. So just beware. Tell all your friends. So anyways, that was the VTEC system. Well, I think they patented it pretty good, or there was other significant problems with it, because what other manufacturers started to do is they adopted a mechanism that went between the camshaft pulley on primarily the intake to begin with, and the camshaft itself. So what it would do is it would change the relationship of the camshaft to the pulley that drove it. And by advancing the camshaft, the engine would run better at higher RPMs. By retarding the camshaft, the engine would run better at low RPMs. As a result, it gave us the same effect, which was a motor that ran well at low RPMs and ran well at high RPMs, because they were moving the camshaft around. Well, that actually worked so well that they started doing it to the exhaust camshaft as well. Now, remember the waveforms I showed you? you could see that now all of a sudden the crank waveform was one place, the exhaust cam waveform was another, and the intake cam waveform was another, because what's happening now is the two camshafts are constantly moving back and forth in relation to the crank. So the camshafts are no longer synchronized to the crank, chronos, time, sin, same. I mean, back in the old days, we would look and make sure that the crank and the cam were lined up. Well, now the crank's here and the cams are pretty much independent to move all over the place. Well, the question is, how are you going to monitor to see if they're moving correctly? Camshaft position sensor. So now we're not just using it for the simple, now we're using it for a pretty sophisticated application of modern technology. Now, do those mechanisms ever go bad? Yeah, they go bad all the time, primarily because people don't change their oil. So what we're doing now is it's given us the ability to constantly be moving the camshafts in relationship to the crankshaft, which gives us, again, the opportunity to have a very smooth running, low emission, high fuel economy engine at low RPMs, and a very powerful engine at higher RPMs. Unfortunately, at least to me, that has led manufacturers to keep using smaller and smaller engines, which I think puts more load on the engine. I mean, it's going to beat the engine up harder, but you know, they don't care. If it lasts past warranty, their job is done, which is, there's validity to that. So my point was, that's way more sophisticated. That's way more sophisticated. And if you're just trying to figure out mechanically whether this thing was working or not, never in a million years, because just like the fuel injector opening pulse width is programmed into the computer, and just like the spark timing is programmed into the computer, you know, this is all high performance auto from Citrus. Well, so is the cam timing. So you would never be able to figure out if this was working correctly, except for the fact that we've got camshaft position sensors on each cam, and the engine knows what it's looking for. And if it doesn't see what it's looking for, there goes on the check engine light, and you're going to have a DTC diagnostic trouble code telling you exhaust cam actuator fault, whatever. So here's the thing. Back when I was Chuck's age, back in the day, engines were very simple. They were very crude. They were very primitive. And, you know, you got to love the primitive, but then again, you know, what's primitive? Banging on sticks with, you know, I mean, banging on logs with sticks. Well, compare that to a symphony. Symphony's got a lot more instruments, and they all got to be in harmony with each other. And it's like, you got to have a conductor, and you got to write out all this music, and you got to have all these different voicings and stuff like that. It's much more sophisticated. It's much more complicated. But when it works awesome.
Yeah.
Right. So that's the big difference. And what we're seeing now is we're seeing some people that are clinging to the old type of mechanics, which was like, well, I fixed my lawnmower, so now I'm a mechanic. And some people who are saying, you know what, I'm going to do the high tech end of this. I'm going to do the high tech end of this because that's a profession. That's a profession, and that's what's going to get you paid. That's what justifies, you know, $120 an hour. In fact, I just had the thought, maybe the reason the shops charge $120 an hour is so that you'll make enough money on brake jobs, because you make money on brake jobs doing it at that rate, that all the money and expense that it takes to do the high-end stuff, you'll still break even. Because to do the high-end stuff, to do, you know, 4-channel lab scope stuff, that takes a lot of money, and it takes a lot of time, and it takes a lot of training. And this is not, if it wasn't for diag.net, what the hell would you do? Or IATN, what would you do? You know, how are you supposed to know? Remember, that's a known good waveform for well, I think it's a 2010 Equinox. if it wasn't for diag.net, if it wasn't for all these people sharing all these waveforms, how would you know what it was supposed to look like? Unless you had the factory scan tool. If even then. So that's what I'm encouraging my students to do. It's like there'll always be people to do brake jobs and clutch jobs. You don't want to do that. You don't want to beat up your back and, you know, be crippled by the time you're 40, 50, or 60. You want to get in there and do the high money stuff. And like I told them, in terms of medium and heavy duty truck, most people go into medium and heavy duty truck because they can't hack the study of the automotive. So if you can get into medium and heavy duty truck or diesel with this level of skills, I mean, everything that's in cars this year is going to be in heavy duty trucks 5 years from now. But the technicians aren't going to be ready for it, most of them. So, little encouragement on that. And this summer, I don't think we're going to have adult school. We don't usually, right? I don't think we're going to have an adult school, but if it's distance learning, why wouldn't you take some classes, citrus, chafee, whatever? You know, folks, there's a lot of people making excuses about why they don't want to take classes. Oh, I don't like distance learning. I want to be in the shop, blah, blah, blah. Yeah, but the simple fact of the matter is this has laid a whole bunch of opportunities wide open for us that if we were smart, we'd take advantage of it. I'll tell you one thing, class size is a third of what it usually is. Okay, so you get more student-teacher interaction. That's got to be good if you got problems. Now, YouTube's got videos over everything.
Yeah.
You know, well, usually. One thing I'm finding now that I'm watching a lot of YouTube videos is there's a lot of errors in a lot of this stuff. But a lot of the errors, they're details that don't really matter in, you know, just getting an overview. So who do I like? South Main Auto Repair. I like South Main Auto Repair, Scanner Danner, Chris Fix, Eric the Car Guy, and Precision Transmission is my new jam. Precision Transmission is my new jam because I was telling the students, you know, I used to be a training man. And I realized, I just like to point out that means I used to rebuild transmissions.
I caught that and I was like, what?
Yeah, it's important to be clear. Okay, so camshaft position sensors. Now, one of the most common failures we get in camshaft position sensors is we get metal filings coming off the cams because they're under a lot of pressure. We get metal filings being circulated through the oil and they stick to the camshaft position sensor because it's magnetized. And as a result, it doesn't function the way we would, well, that we need to. In fact, it'll stop functioning. So a lot of times if you just take it out and clean off the magnetic filings and put it back in, you can have success. All right, so that's the two on the engine, but there's one more that affects engine operation. Let's see where we get. VSS. VSS is the vehicle. Questions, comments on that? Vehicle speed sensor. This is the first time I've ever taught this lesson, so that's why it's a shame to miss it. Vehicle speed sensor. Okay, vehicle speed sensor is located on transmission output shaft. People think there's some magical way that it measures vehicle speed. It doesn't. It's inferring the vehicle speed from other things. Now, the output shaft of the transmission is connected to drive axles. The drive axles, which are the axles that actually make the wheels turn. And drive axles, that's a semicolon. Drive axles are bolted to wheels, to the wheels, whatever, using lug nuts. Okay. Now, tire circumference is a measure of how far the tire is around. And if the drive axle is bolted to the wheel and the drive axle is connected to the output shaft, there has to be a constant mathematical relationship between the speed of the output shaft and how much distance is covered by the tire. What is this, 2 pi r? Circumference of a wheel, circumference of a circle is 2 pi r, I believe. 2 pi,
Yes.
yeah. Mhm.
No.
Well,
No, 2r. Yeah, 2r pi. Like it's the diameter times pi.
right.
It's 2 radius times pi.
Oh,
Yeah.
it's pi d, that's right,
Yes.
which is the same thing.
Yeah.
Pi d.
Yeah. Well, anyway, you multiply them all, so it doesn't matter.
Uh-huh. Well, that's the radius right there. So there has to be a constant relationship between how fast the output shaft spins, as long as this tire diameter remains the same. Shoot, maybe I should just go like this. Tire diameter, not wheel diameter. As long as the tire diameter remains the same, there has to be a constant relationship between the amount of distance traveled by one rotation of the tire and the speed of rotation of the output shaft. Okay. What if you change tire diameter? That goes away.
Mhm.
Yeah, which is the problem, because what happens is people change tire diameters. Now, the vehicle speed sensor will still work, but it won't be accurate. Or if you see people with cars and what they do is they use the same size wheel, but now instead of regular tires, they put on low profiles. It's going to change the tire diameter. Therefore, the circumference will be different. Therefore, you won't be covering the same amount of distance for every rotation of the output shaft. Therefore, your vehicle speed sensor will not tell you the truth. That'll make your speedometer wrong. That'll make your odometer wrong. And that will also change your shift points. You know, where the transmission shifts. Now, usually this is another trigger wheel on the output shaft. Now you can get different modules for different, you know, drive axle ratios for different tire diameters to see if you can restore the accuracy of your vehicle speed sensor. But otherwise you could have some problems. In fact, you could have a problem. What they noticed, like on the C5 Corvettes, if you changed your gear ratio, rear end gear ratio from like 273s to 315s, you could get to the point where it wouldn't shift into fourth gear by 100 miles an hour. Because the vehicle speed sensor was reading incorrectly, inaccurately. So that's something you need to be aware of. It's not really measuring vehicle speed, it's measuring output shaft speed. And the problem is you got to maintain the proportion of output shaft speed to tire circumference. All right. Here's another thing that's really cool. The ISS and the OSS. That's input shaft speed sensor. And output shaft speed sensor. Automatic transmission. Well, we know that we got misfire detection out of the crankshaft position sensor. The ISS and the OSS are going to do something really dynamite for us in terms of automatic transmissions, because automatic transmission is going to have a torque converter, which has a fluid coupling. And it also has clutches in it, which is another fluid hydraulic device. So let's talk about input shaft. Input shaft is the shaft that comes into the transmission. It's driven by the engine. Output shaft is the shaft that goes out of the transmission that's splined to the drive shafts or the axles, or depending on the setup. Well, there's a torque converter between the engine and the input shaft. And the torque converter has a torque converter clutch, which locks up the flywheel flex plate at the back of the crankshaft to the input shaft, so that the crankshaft and the input shaft are going to be turning the same speed. Well, sometimes that torque converter clutch starts to slip when it gets old, or when it's lacking fluid pressure, or a million other reasons. It starts to slip. How would we know that? Well, the computer, the PCM, is going to be comparing the crankshaft position sensor signal to the input shaft sensor signal. And if the torque converter clutch is locked up and holding, they should be exactly the same. If the engine's going 1,000 RPM and the input shaft sensor is only going 800, you've got slippage in your torque converter, and it's going to put up a code, tell you you've got a bad torque converter clutch, way before you would be able to figure it out yourself. So the cool thing is, now these transmissions aren't going to leave you on the side of the road. They're going to let you know they're failing way before they actually fail, which is cool. Now, let's say you've got a second gear ratio in your automatic transmission of 3:1. That means that if your engine is going 3,000 RPM, your output shaft should be going 1,000 RPM. But what if your engine is going 3,000 RPM and your output shaft's only going 600? That tells you that your clutch is slipping, second gear clutch is slipping. On goes the light. So what this enables us to do is it enables us to find a transmission that's on the way out before it leaves you on the side of the road. That's awesome. Now, you know what Cummins is doing now? Cummins, as soon as you get a diagnostic trouble code and a light comes on, it sends that straight to Cummins. And then Cummins searches your area for Cummins authorized repair depots and sees who has the correct part to fix that in stock. And then they direct you to that one. That's pretty awesome. Yeah, it's awesome for Cummins, but yeah, I mean, that's what we're doing with the modern technology. So we're making big time advances. I mean, Cummins has got what, 80% of the on-highway market, maybe higher, because Caterpillar couldn't make the Tier 4 smog emission standards. So I think Cummins has almost sewed up the market. If it wasn't for, International Harvester, and who makes diesel motors, Isuzu? But it's got to be way over 80%, especially the heavy duty side. Too bad we don't have a Cummins factory school 5 miles away. Oh, that's right, we do. It's called Citrus College. Yeah. David Burks, Chuck Reyna, yes. I got to tell you, it breaks my freaking heart to know of these opportunities available to these young people, and they don't care. I ask them what their plans for the future are.
They don't know.
They want to be YouTubers.
Okay, HBO has a special on right now called Fake Famous. You got to see it. I mean, the whole thing is all this YouTube influencer stuff. It's all fake.
No, it's all fake.
It's crazy, and that's what they all want to be. These are actually these young people's heroes. I'm like, damn, you know who your hero should be? Your dad that's got 2 jobs so he can keep you in iPhone 12s. Right?
My ex-girlfriend's current boyfriend, he's 39 years old, doesn't work. He calls himself an entrepreneur. He's trying to be a YouTuber. Yeah, and I just laugh. I'm like,
Yeah.
what?
Boy,
Oh,
she really traded up.
oh yeah. I'm like, go for it.
He's not going to make a rap video about making EDD fraud, is he? Hey, did you catch that? The chick that was in charge of $600 million worth of unemployment fraud in the state of Washington has now become the federal government person in charge of watching over unemployment fraud.
What?
Yeah, because I think the majority of that unemployment, I suspect, maybe I shouldn't say this. I end up getting it. That's whatever. Yeah, they'll close my Bank of America account. I suspect that's a money.
You're recording.
Yeah, I know. I suspect it's a money. Okay, some crazy guy told me maybe it was a money laundering scheme where, you know, like the money goes out and then it comes back in terms of kickbacks. That's crazy talk, though. Only crazy people would think that, and seditionists, insurrectionists. So my point was, so this enables us to do fantastic things with the automatic, in terms of diagnostics, in terms of automatic transmissions, which is important when you've got an 80,000 gross vehicle weight, 80,000 pound gross vehicle weight truck. It's real important that you start seeing transmission before it breaks down entirely. Plus, this allows us to do adaptive things like have faster shifts or shift sooner or stuff like that. So, you know, in case you're wondering why the new Allison transmissions cost like 25 grand, that's why, because they've got this technology to them. Now, can old school guys work on this kind of stuff effectively? I'm not sure, but well, they better learn or die, because the old school stuff that was purely mechanical, nah, that's 40 years old. So. Thanks, Anna. All right, so where are we at? One more thing? Yeah, one more thing. I think I'm going to turn the next page. You got that?
Yep.
Okay. Wheel speed sensor. Sorry. Wheel speed sensor is primarily used in the ABS, which is the anti-lock braking system. So we've got one computer and we've got wheel speed sensors on each wheel. And we know that the frequency output of these wheel speed sensors is going to be proportional to how fast the wheel is turning, which tells us that all 4 sensor outputs should be the same, because all 4 wheels should be turning the same speed. Well, do yourself a favor and don't change your tire diameters 2 at a time, because that'll screw it up. It can potentially set a ABS code, even when there's nothing wrong. But how it's supposed to work is you're supposed to have the same tire diameter on all 4 tires. And as you go down the road, all 4 tires should be turning at approximately the same speed, within 10% or whatever. Because of course, when you turn a corner, the outside tire has to turn faster. So what happens? Well, the analog braking system is there to stop one wheel from skidding, by which I mean to say the wheel stops turning and you're just skidding, which is to say you're rolling on little balls of rubber being carved out of the bottom of the tire, which means you have no traction there. So you have no steering. So what the ABS computer is going to do is it's going to compare the speeds of all these 4 tires. And if it sees wheel speed either at 0 or going down to 0, when you're braking, what it's going to do is it's going to release the brakes to that wheel because it can see that it's either in a skid or it's going into a skid, and that you would lose control. So it's going to release the brakes to that wheel so that the speed can resume climbing again. And 20 times a second, it's going to apply the brakes. Back in the old days, when we had drivers training, they used to tell us, pump the brakes so you wouldn't go into a skid. Well, now the ABS unit pretty much does the same thing, except it's doing it 20 times a second, way faster than you could unless you were in Riverdance. That was a joke. Riverdance joke. Never mind. Anyway, the point I was trying to make was that, so it's doing it 20 times a second. So it's monitoring, actively monitoring the wheel speed sensors, and it's applying and releasing the brakes to make sure that your wheels don't lock up. That's how ABS works. And it's way more effective than you could ever be at stopping a vehicle. Now, traction control is the other side of that coin, just like an engine is, electric motor is the opposite side of the alternator coin. I mean, the electric motor turns electric energy into mechanical energy, and the alternator turns mechanical energy into electrical energy. It's just opposite sides of the same coin. Well, traction control does the opposite of what an analog braking system does. It's still going to be monitoring the wheel speeds of all four wheels. But for instance, if 3 of the wheels said that they were going 30 miles an hour and the other wheel said it was going 120 miles an hour, well, obviously that's doing a burnout. So what the system would do, the traction control system would do, is apply the brakes to that wheel. Why? Because a conventional differential will always give power to the tire with the least traction. So if you have one tire on ice and one tire on asphalt, it's going to give all the power to the one on ice, which means you're stuck. That's why conventional differentials suck, and why everybody down south has positive traction, which you would know if you would watch My Cousin Vinny enough. So what it does is, if you have 3 wheels turning 30 miles an hour and the other rear tire, or drive tire, I should say, is going 120, we're going to apply the brakes to that tire. And when we do, the power is going to be transferred from that tire that's spinning to the other drive tire. So as a result, you're going to be spinning ain't winning, right? So it's going to propel the vehicle forward instead of just, spinning the tire and burning rubber. That's the essence of what I believe like Toyota's electronically locking differential. I believe that's what they're actually doing, is they're just applying the brakes. That's typically how they do traction control. And it's tremendously successful because what it does is it just keeps your rear tires from being out of control. Or at least it does on the C5. I think I've seen it function once in the Z06, which I don't really understand, but I love it. So that's what traction control does. It's just the other side of the coin. It's the exact same mechanisms. It's the exact same process. It's just the opposite application. And that, folks, is, I believe, what I have to tell you about these inductive pickups and their use as speed sensors, or, no, I got one more. I got 6 minutes. All right, back in the day, we used to have breaker points in the distributor. That's how we used to control the coil, back when we had one coil for all the cylinders. And we had breaker points, which is a mechanical switch. Problem with the mechanical switch is it wore out. And when it wore out, it changed its adjustment. And when it changed its adjustment, unfortunately, it changed the ignition timing. When it changed the ignition timing, it changed the way the engine operated. So about every 3 months, you would have to take your car in for service to get the points adjusted. Well, that was no good. And another big problem we had with it is we couldn't get the voltages we need for the bigger spark plug gaps that we wanted to use because we were worried about this emissions issue. So about 1974, we came out with what was called electronic ignition. And sure enough, the electronic ignition had a trigger wheel, which would spin. It's where the breaker point rubbing block used to be. And then we would have a pickup coil just like this. This would be for a 4-cylinder engine. And every time this big old tooth came close to this coil, an AC signal would be sent. Sent where? Well, we'd send it to what we called an ignition module. And the ignition module, so it was a 2-piece system. The ignition module would amplify the signal, by which I mean to say, make it bigger, because like I've showed you, this is like a millivolt signal, and we want something way bigger than that. And refines, so the ignition module is going to amplify and refines. And when I say refine, I'm really saying rectifies. Pickup coil output. So look, the breaker points were a switch, so it would be digital. It's either on or it's off. Well, alternating current is not digital, it's analog. It's a whole bunch of different values, an infinite number of values. Well, you can't really make a coil's magnetic field build and collapse with an analog signal. It has to be digital. So what we had to do with the ignition module is we had to make the signal bigger, and we also had to make it a digital signal instead of an analog, on, off, on, off, on, off. And that gave us the coil output we wanted at a higher voltage, which allowed us to increase the spark plug gap, which, you know, the manufacturers went from 35 thousandths of an inch to 45 thousandths to 60 thousandths to 80 thousandths to 100 thousandths on a couple of cars. And then now we're all back about 45. But back in the day, they were experimenting because they were desperate to try to figure out how to get these emissions down. Turns out it took a complete redesign of the engines. Because basically they were tractor engines until the 90s. Well, even still, nobody cared about efficiency or emissions or stuff like that. So you got the LS motor. So you're often going to see this phenomenon. Oh, remind me, we have to talk about Hall effect. Do we have to talk about Hall effect? Yeah, just for a moment. Yeah, we'll talk about Hall effect when we come back. So very common that when you have this kind of arrangement, which you're going to see a lot, magnetic sensing, you're going to have something to amplify it, and you're going to have something, you're going to want to have something that makes it a digital signal, because this analog signal is hard to process. And in a lot of ways, it's not what we want to accomplish what we want to do. So when we come back after break, we're going to talk about Hall effect sensors, and you'll see probably the most common automotive answer to that question of how do we get that digital signal. Yeah?
Yeah.
So I'm going to quit recording so you can share your conspiracy theories or does it stop recording? We don't know. Pause recording. Thank you, because I thought I did. All right, so this is just an electromagnetic sensor, but there's another sensor which between the two of them probably comprise 95% of the sensors you're going to see on a car. And it's called a Hall effect sensor. And there's important differences between the Hall effect sensor and just the regular pickup coil. Now, we've discussed, I believe, in this class that you can just test the pickup coil with an ohm meter, or you can just hook your voltmeter to the coil and spin the wheel and see if you get a AC voltage output. But it's going to be millivolts. In fact, it was strange because I was watching an instructional video from this Australian guy, he actually had an output shaft in a lathe and he was spinning it and he had the pickup coil right next to it, but he had a cheap meter and he had his meter set on 200 volts and he wasn't getting any output and he didn't know why. I was like, dude, if you just put it on millivolts, it'd be bing, 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 because he didn't have an auto ranging meter. I'm telling you folks, you need to get that auto ranging meter. That's why I don't bother teaching non-auto ranging meters anymore. It's just too complicated. It makes the job, it makes learning how to use a meter effectively like 98 times harder. It's also why I don't teach measuring amps with meters, with that kind of meters anymore either. It's just asking for it. Okay, so a Halifax sensor is going to be a 3-wire, but more importantly, it's a powered sensor. Either 5 volts or 12 volts. But it's a powered sensor, which means if you disconnect it, it won't have any output. And you'll think, oh, it's bad, because you'll be thinking you'll be testing one of these, but you're not. So a Halifax sensor is going to use power because basically what it is it's effectively doing the job of the pickup coil and the ignition module because it has a digital output, which means you don't have to put it through a signal converter. That's the advantage of the Halifax sensor. So you end up with a digital output. Well, that's groovy. You just got to make sure you know which one you're testing. Now, even the cheap meters now, even the cheap scan tools now, this stuff will give you a graphic readout of your sensor output. So we don't have to work as hard to test our sensors as we used to, because it used to be you would have to get out the oscilloscope and figure out which wire to use and maybe back probe and all kinds of stuff like that. But we're past that point now. So now, like when you look at South Main Auto Repair, you're going to see basically what we have to do now is we have to figure out whether our issue is the sensor itself or the circuit that the sensor goes to.
Just real quick, may I ask a question?
You just did, yeah.
The Halifax, is that a light emitting diode? So when the beam is broken, it triggers it, or?
That's an optical sensor. That
Okay.
also comes out with a digital signal. Yeah, you're almost as old as I am. Yeah, let me show you a marginally useful video right here. All right, Mr. Lopez, you got to get your connectivity issues handled, my friend. Yeah, there you go. All right, so that's an inductive sensor. That's the pickup coil. Okay, right there.
Usually shielded with a coaxial coat.
Sorry.
Wires type of protection.
Sorry.
Hall effect sensor operating principles and specification. Unlike inductive sensors, the output signal from a Hall effect sensor is not affected by the rate of change of the magnetic field. The produced output voltage.
Technically not correct. The output is affected, the frequency is affected, but not the amplitude, not the voltage. But that's not the big thing about the Halifax sensor. The big thing, as you can see, is that the output is digital.
Typically is in the range of millivolts and is additionally amplified by integrated electronics fitted inside of the sensor housing. Figure 2 shows a typical build of a Hall effect sensor. The final output voltage signal usually is in digital waveform pulses. The output signal of a sensor can be either positive or negative with peak voltage usually up to 5 volts or 12 volts, depending upon the type of the integrated electronics and requirements of the used system.
So first of all, it's got a way higher voltage output. Now, why is that important? Because I think we studied enough Ohm's law to know that a little bit of resistance is going to have a much greater effect on a millivolt signal than it's going to have on a 12 volt signal. Let me prove that. Still got the trigger wheel though. Let me make that theoretical point because it's an important thing to note. Go to advanced content. There we go. Go to the next page. All right, so let's say I've got a 2-volt battery, whatever. Now let's make the first one 12 volts just for fun, just for familiarity. And let's say we have a there you go, 1 ohm resistor. PEIR. Did we do this in this class? The Ohm's law? Been so long, I kind of forget.
Yeah, we did the math formula. Yeah.
All right. Well, we've got 12 volts over here, plus. So E is 12. Got 1 ohm resistance there. So we multiply up and divide down. 1 times what equals 12? 12 amps. 12 times 12 is 144 watts, just for fun. We don't need it for this exercise, but we'll just do it for practice. So 144 divided by 12 is 12. 12 divided by 12 is 1. So we multiply up and divide down. That's why I always set things up this way, because it makes it super easy and I don't have to take a bunch of intermediate steps. Okay, well, let me cut down on this voltage to 2 volts, right? Because the Halifax sensor has an output of either 5 volts or 12 volts. The pickup coil has an output that's going to be in millivolts, or it might be 1 or 2 volts max on a good day downhill with a tailwind. So let's come over here. There's my battery. Come over here like this. Now, the same resistance, 1 ohm. But let's see what effect that has on the way the circuit operates. PEIR. E is 12. R is 1. No, it's not. E isn't 12. It's 2. I'm sorry. I was wondering why that didn't work. What's your current flow?
2.
2 amps. Yeah. So what's your total power?
4 watts.
4 watts instead of 144 watts. See that? One of the major reasons we want to use a Halifax sensor is because the output is way higher than a pickup coil, way higher. And as a result, if we have, because resistance in a circuit is very easy to come by. Every connection has resistance, every wire has resistance. And if we have a long run of cable, especially if we have some kind of connection issues, chances are good that all that resistance is going to effectively bring our output voltage to next to nothing by the time it gets to the computer. Next to no current, next to no signal. As a result, it makes it much more likely to have a failure related to that signal. That's why, it's like back in the olden days, back when I used to be Chuck's age, people used to get, back when CB radios were big, people would get these monstrous power resistors, and the legal limit was like something like 5 watts, and they'd be kicking out 20, 40, 50, 60, 80. I would have, people would go up Glendora Mountain Road and they could talk to people in San Diego with a CB radio, which isn't supposed to be able to transmit over like 5 miles. So what does all that power do? It cuts through the resistance in the air. It cuts through the static. It cuts through radio frequency interference like I'm getting from all these power supplies. Because you got to realize that an engine is putting out all kinds of radio frequency interference too, especially the ignition system. It's making all kinds of inductive voltage, just like this computer power supply here is. Everything electrical is going to put out a signal unless it's shielded. Coaxial cable. And most stuff isn't going to be, because that's a very expensive method of cabling. while we're on that topic, let me show you coaxial cable. This right here is the conductor or signal. But around that, we are going to have a grounded conductor that looks like this. And what does grounding the outside do? In fact, that's how a guitar cord works. That's the difference between a guitar cord and a speaker wire. And yes, just because I'm cool as hell, I do have guitar cords installed. And of course, they're all going to be impossible to open up. So let's see. But how a guitar cord works, I didn't know I had that. Where'd all this come from? I'm going to get these apart with my hands. Anyways, oh, it's because they're actually, okay, so what you have to do, since this has got a signal coming down, since that's got a signal coming down that nub, this is the signal, there's an insulator, and there's the ground. So the signal goes through the middle, and it's surrounded by braided cable, which is going to protect it from interference from radio frequencies. That's why a lot of times when you hear people playing guitar live, you can hear this bah 60 cycle hum. Yeah, especially under fluorescent lights, it used to be terrible. So better cables, the reason these guitar cables are like $30, $40 is because the better cables gave you 100% coverage of the signal wire. The cheaper ones gave you like 40%. As a result, they were much noisier cables. Okay, so there I was at Mr. Mike's in Covina on Citrus, playing and singing the blues. And I was playing my amp, which was grounded. And I also had my microphone, which was grounded, but they weren't grounded to the same thing. One was grounded to the hot, one was grounded to the freaking neutral. So as soon as I got ready to start my song, I played my first intro lead, and I went up to sing my first note, and my lips hit the freaking microphone, and there was 120 volts between my hands and my lips.
Oh,
Yeah, that was awesome. And that's when I learned, children, we don't mess around with grounds. Well, I mean, a lot of these places, I mean, it's a little freaking dive bar. And the problem was they didn't have grounded outlets. They just had 2-wire stuff, and we were using adapters. And one of them was wired backwards, probably from some electrician who didn't go to school.
wow. When was it?
Probably charged $9,000. When was that? That was back in 87-ish, something like that. Gee whiz. Yeah, back in the day. Back when girls used to scream when I used to sing. You know what they'd scream? Turn off his microphone. That was a joke. Not really, though. Yeah. I'm so glad I did all this stuff when I did, because once you get old, Chuck, you're going to find this out someday. Once you get old, you lose certain powers that will not return.
Yeah.
So anyway,
Wait, I have to ask, what type of music?
we were playing the blues, man.
Yeah.
Talking about my sad life.
The blues.
Playing that, yeah, of course.
Hey,
Yeah, you have no idea. That's called coaxial cable. Coaxial means they're both on the same axis. Yeah. The weird part is me and Michelle used to freaking run around the same circles back in the 80s. She had a band. I had a
you
number
just
of
did
bands.
not know that.
Right. Yeah, isn't that weird? But we all know the same people. It's kind of weird.
Yeah.
Anyways, yeah, good times. So anyways, my point was that's coaxial cable. Basically, it's what they call shielded cable, I think would be a good way of putting it. And what it does is creates what's called a Faraday cage. And a Faraday cage stops charges from getting inside it. It's like putting your key fob in a metal box will keep people from stealing your car, because there's radio communication between your key fob and your car. And what these people are doing to steal modern cars is they're using a laptop to boost the signal coming from the car. So now the car thinks the key fob is right next to it when it's 50 feet away or 100 feet away, which means now they can open up the car and they can, I mean, the car will start and away they go. That's the modern way to steal cars, with laptops. That's why if you have a push start car or a car with a key fob, you want to put your key fob in the metal box when you go to, when you come inside. That's the way to protect it. It creates what's called a Faraday cage, which, I mean, you could sit inside a Faraday cage inside a Tesla coil and not get zapped. It's called shielding.
How close or far do they need to be for that to work?
I think it would depend on the strength of their laptop, but they could be.
Okay.
I don't know. The question is how big of a chance do you want to take?
I'm curious because I see posts of people saying, oh, they broke into my car. I forgot to lock my car. And I get that people might forget that, but I just think maybe they did and they don't realize that they're being broken into that way.
Right. Yeah, exactly. I think that's what's happening. Because I
think to myself, like, I always lock my car, and I know everyone has a habit and you might not lock it for whatever reason, but I see a few posts like that and I think, like, you would know whether you locked it or not. So I'm wondering if that's not the way they're breaking into them, and the people think, oh, I must not have locked my vehicle.
Right. Because it's not forced entry. Yeah, exactly.
Yes.
So I got a little metal box. I'm not going to drive my Corvette regularly, which I wish was usually. I just put the key fob in a metal box because
you could use aluminum foil too, right?
Sure, or you can put it in the freezer. Yeah.
Yeah, foil.
Yeah, you could use aluminum foil, but that seems like more work. Yeah, you mean like my hat? You mean like my hat when I'm talking about Governor Newsom? Yeah. Bank of America. Quack. Anyways, my governor. As you can see, our governor. Yep. So my point was that if your signal is very small, is very weak, it's very susceptible to degradation, whether by outside influences or by resistance. That's why it's great to have a really strong signal like what you get out of a Halifax sensor. Now, is a Halifax sensor going to be more expensive? Yeah. Is it harder to test? Yeah. Well, it used to be, but now with scan tools, modern scan tools, we can check the output with a scan tool. Now, let me put it this way. If, it's relatively easy to check whether, and this is what South Main Auto is trying to teach us, is we don't want to just replace the sensor. We want to check to see if the system is working correctly. So we don't, buy an electric part that we can't replace. On a Halifax sensor, we want to check to make sure that it's got the power coming in. That's usually the main problem you're going to have with Halifax sensors. So it's just an extra step. Have we talked about back probing in this class? Have I drawn you a beautiful picture of it? Take that as a no. So let's go like this. Back in the olden days, we used to use just electronic connectors that you would find in your computer, your desktop computer. Problem was they weren't weather tight. And since they weren't weather tight, what happened was in the environment of the engine compartment, which is wet and hot and dirty and greasy, what we would get is we would get accelerated corrosion of the connections. Now, especially when you're talking about millivolt outputs, like all the sensors pretty much, except the Hall effect, a little bit of resistance, a little bit of corrosion causes enough resistance to throw your readings off. And now all of a sudden your car thinks, your computer thinks your engine's at 130 degrees when it's actually at 210. What does that matter? Well, that matters a great deal when it comes to spark advance and fuel pulse width. So what we came up with now is we came up with different connectors called weather tight connectors. And weather tight connectors actually have a seal around the wire in the back and in the front so that weather can't get into the connector and cause that corrosion and resistance and screw up the accuracy or operation. Well, here's the problem though. If you hit this thing with, you know, one of those things at the coin car wash, if you hit this thing hard enough, it's going to have enough pressure to blow crap into the connector, but there's not going to be enough pressure to get it out. So it's just going to sit in there and fester like abscesses. You know, it's like there was a whole show today on Dr. Pol on draining abscesses. You know, because I was having this conversation with the kids today about, you know, being an adult means you spend a lot of your time doing stuff you don't feel like doing. Because their teachers are telling them, oh yeah, you look forward to going to work every day. That's
you
the kind
don't.
of job. Yeah. So my point was draining abscesses. I'm not sure how it could be fun. I mean, it could be rewarding in the sense that you could see that you're alleviating the animal's suffering, and it could be rewarding in the sense that it pays well, and it could be rewarding in the sense that you see that your diagnosis leads to a cure. Okay, so here's a connector, but I can't imagine it's fun. It smells like hell. You know, he was doing it to a bull, and the bull's like, what, 2,500 pounds? He's like, this thing kills me. It's just going to kill. I mean, this thing kicks me. It's just going to kill me. You know, so I can't imagine it's fun, but that's the back of a weather tight connector. As you can see, it's got a seal here and a seal here. Now, if we go and shove something big inside that between the wire and the seal is not going to close back up. As a result, weather is going to get in there. So there's this thing called a T-pin that we usually got at, well, let me draw it over here. That we usually got at, well, I used to get it at Walmart, sewing supply. Looks like that. It's used for sewing. It's called a T-pin. And you can bend that rascal, and you can stick it in here until it makes contact with the connector. And then you can put your voltmeter lead on that. Well, I'll draw one just for fun. That's a test lead. This phenomenon is called back probing. And Professor Brown over at Sensors told me last time I talked to him that Toyota has now determined that there will be no, there is to be no back probing, period. No more back probing, because they're having problems with the seals, of course. It leads to corrosion and it leads to problems down the road. So no more back probing according to Toyota. I would be very, very careful if I was doing back probing. You know, if you shove this thing in too hard, first of all, the seal may not close back up, which would be one problem. But one of the big problems we have with back probing is people are getting between the pin and the connector, and they're spreading the connector out. Now when they take the T-pin out, it's not tight on the pin anymore. I believe that's what happened. If you guys were here long enough ago, I believe that's what happened on the Silver Corvette. That's why the hatch wouldn't open when you press the button, because the connector got too big and it wouldn't make contact with the pin anymore. So they have all kinds of retentioning tools to squeeze down that, but you know, that's work. That's work. And that's the kind of stuff where if you took your car in and they had to fix it that way, better bring a checkbook. So that's back probing. As I say, Toyota no longer considers this a legitimate diagnostic method. But what it did was it allowed us to hook up an oscilloscope and check for voltages, outputs, signals, whatever. This is called a weather tight connection. So be careful with your back probing. And as I say, if you get a good scan tool instead, you're probably going to be able to graph almost everything you could get by back probing anyway. Now, does using an oscilloscope directly on a sensor allow you to see if it's the sensor or the system, if it's not working correctly? Yeah, but it's 58 times more work. If you can do it with a scan tool, you should do it with a scan tool because that's by far the fastest, easiest way to do it. All right. Did we talk about series and parallel circuits? That's my question I was thinking today. I'll take that as a no.
Nope.
Any questions about back probing or anything we talked about tonight? I get started on this. This is going to help out my good friend Gabe. Let's go this way. All right, so here we go. A little practice, get us back in the mood. Light bulb, 4 ohms, and then we go this way. 12 volts DC, that's the positive. PEIR. Okay. You done yet? Resistance is 4 ohms. Now, folks, if you're not quick on this, you need to get quick on this. How do you get quick on this? Just make up yourself different numbers. Do the exact same formula. Do the exact same drawing with different numbers, and you'll get quick at it. E is volts. So that's 12 volts. 4 times what is 12? 3 amps.
3.
3 times 12 is how much? 36 watts.
36.
Yep, 36 divided by 12 is 3. 12 divided by 3 is 4. So that way we can check our work, right? Well, this is called a simple series circuit. Simple series circuit. Why? Because every part of the circuit happens one after the last. And there's certain things about a simple series circuit that make it very, very useful and interesting to us. And I'm going to teach it the way I taught it back in East LA because it was a very effective method that everybody could understand pretty well. Okay. So we say 3 amps. 3 amps is a measure of electrical flow. It's a number of electrons. Okay. At a certain rate. Okay. If I got 3 amps over here, where did they come from? Any electron that gets over here to the load, where did it come from? Comes from the power source, right? Every circuit has 4 parts. Power source, load, controls, and the conductors that connect all the parts. So every electron that goes through this filament came out of this battery, right? Right?
Yeah.
And every electron that goes through this filament is going to end up over here, right? So,
Yeah.
right? So if I have 3 amps of flow at the bulb, I must have 3 amps coming out of the battery, yes? And 3 amps coming in this side of the battery, yeah? So how many amps are there on this wire?
Also 3.
It's got to be 3. How many amps are there on this wire?
Also.
It's got to be 3. It's the same everywhere. So in a simple series circuit, current is the same everywhere. So if I was going to put a switch in here, it would have to be rated at 3 amps. Here's how I taught it in East LA. 3 Sanchos climbed in the window. Yeah, 3 Sanchos climbed in the window. How many Sanchos came down the street? 3.
3.
And then how many Sanchos ran down the alley?
3.
Also 3.
Yeah, has to be. See? Joe's like, damn, this is so easy. No, I understand. Okay, so here's the thing about that. Now, that's just for one load. But that also tells us why we don't want to use, you know, a regular switch for, say, the starter. Because if there's 250 amps at the motor, that means there'd have to be 250 amps at the switch. 250 amps is a bigger switch than you have on a 200 amp service. That's a kaboom, kablunk. No, starter switch is like this. How? Because it's controlling a relay. We've got milliamps controlling hundreds of amps. That's why we use a relay. That's also why we use a relay to control the fuel pump with the computer, right? We're using milliamps through the computer to keep it cool, to control what, 30 amps, 10, 15, 30 amps at the fuel pump? Because we use a relay, a small current to control a larger one. All right, let's see. Let's do something like this. Want to do parallel first? Here we have 2 light bulbs. See that? PEIR. We didn't do this recently. So that's P total. This is total. This is going to be PEIR sub 1, just like that. This is going to be PEIR sub 2. Why? Because this is going to be resistor 1. This is going to be resistor 2. They're both light bulbs, but now we know. Now we need to start figuring out some important things about what's going on electrically. Write down what we know. Right? It's always the first step. 12 volts DC. So E total is 12 volts. We know that much. We know that resistor 1 is 2 ohms. We know that resistor 2 is 2 ohms. Now my question to you is, how many volts is resistor 1 getting? Look at the drawing and see if you can tell me.
How much resistance?
How much voltage is resistor 1 getting?
12.
Well,
Yeah, it's getting 12. Good. Okay, remember, if you know any 2 things about about this column, you can solve the rest.
Yeah.
My next question, before you do that though, how many volts is resistor 2 getting?
Also 12.
Also 12. Good. Okay, so solve. 2 times what is 12?
6.
6
Six.
amps. 6 times 12 is what? 72
72.
volts.
72.
And they're both the same. 6
Mhm.
amps. Okay. So let me ask you a question now, because this is the important part. If 6 Sanchos, because the amps is the Sanchos, if 6 Sanchos jump in this window and 6 Sanchos jump in this window, how many Sanchos came running down the street?
6.
That's not the same.
Six.
They're not that young. Yes, 12. Right.
Okay.
Or we could say if this light consumes 6 amps and this light consumes 6 amps, how many total amps are consumed?
Then 1.
Well,
Let me put it this way. If 6 gallons per minute comes down this branch of the river and 6 gallons per minute comes down this branch, how many gallons per minute do you have right here?
6. No, 12.
Got to be 12, right? Because 6 goes this way and 6 goes that
It's
way.
going- Yeah.
Yeah, so total is 12.
Mhm.
Okay, well, let's do this though. Multiply up. 12 times 12 is 144 watts,
Correct.
which should make sense because if this bulb consumes 72 watts and this bulb consumes 72 watts, total power consumption is 144 watts.
Mm-hmm.
It's like if this cop ate 72 donuts and this cop ate 72 donuts, how many donuts got eaten in total? 144, right? Because power consumption is like consuming food. Yeah, okay. 12 divided by 12 is what?
1.
1 ohm. So the total resistance is 1 ohm. Total current flow is 12. Total power consumption is 144. And this right there is called a parallel circuit. And that's the two type of circuit. There's series and there's parallel. They're flip sides of the same coin, which is the good news. Just like we've been talking about, you know, motors and generators are flip sides of the same coin. And ABS, wheel speed sensors, and traction control wheel speed sensors, two sides of the same coin, opposite applications of the same mechanism. Okay, so let's study this parallel circuit a little more because I think it's easier to learn first. It's much more intuitive because this is how circuits are actually wired. For instance, if we were doing a tail light circuit, or if we were doing 2 lights in a room, we would use a parallel circuit. Why? Because that way both lights would be getting full voltage. So let's check. Let's see. Parallel circuits. Sorry. There we go. Let's make pretty much the same drawing. And as I say, if you want to get fast on making these drawings, and on solving these problems, and you should,
ooh,
just make yourself a problem like this. What's going on with Michelle? She okay?
she didn't respond,
Ooh,
so I hope she's okay.
yeah, I hope so. PEIR. Gabe, are you familiar with the pushmatic breakers for services?
Those are the old ones, aren't they?
Yeah.
Yeah.
Aren't those really valuable? Are those the ones, the big ones made of Bakelite, and they're really, really valuable, like 60, 70 bucks a piece because nobody makes them anymore?
Mm-hmm. There's a place in El Monte that they pretty much, my boss, every time we go and we demo a place out, he gets all those and he takes them over there to that spot in El Monte and they rebuilt them and then they sell them, you know, for
Fortune.
Yeah, a fortune, exactly.
Yeah, you want to know the best part about this $9,000 service job? They took all the old breakers with them.
Oh, see, yeah.
Which is probably another 1,500 bucks.
Damn, they got jacked.
Yeah, well, that's what people do. I mean, they don't know. See, but they saved $80 from not taking my class. I mean, one of the things that we profit from in this class is the connections, right? Because, you know, we know a whole bunch of people in a whole bunch of different fields, right? Just wait till you have one of Michelle's cupcakes and then you'll You'll understand. Okay, so let's make this, I don't know, 4 ohms. 4 ohms. All right, so what do? Start off by writing down what you know.
It's 12, so
4 ohms, 4 ohms, 4 ohms. How many volts are we getting at these light bulbs?
12
Good. Which one?
each
12.
one.
Good.
Yeah, each one got 12.
Okay, well, once you know 2 things, you can just run the table, right?
Yeah.
3 amps, 36 watts. 3 amps, 36 watts. Well, if this cop eats 36 donuts and that cop eats 36 donuts, how many donuts got eaten?
72.
72.
72. Okay. 72 divided by 12? 6.
6.
12 divided by 6 is 2.
Cool.
Done. That's how long it takes. Parallel circuits. Now, look what happened. I had two ohm bulbs on the first exercise. So I had 12 amps total current flow. I have 2 4 ohm bulbs, twice as much resistance over here. So my current flow got cut in half because the resistance was twice as high, right? I got 2 ohms here. I got 1 ohm over here. I got 144 watts over here because my resistance was low. And over here, I've got 72. You never believe what's about to happen. You never believe what's about to happen. You never believe the wonderful thing that's about to happen to us. Watch. Listen. I think. Well, he might be only marginally here, but he's just in time because he used to teach this. See, back in East LA, probably 75% of my students were English language learners. So what Rudy would do is I would pay him whatever to teach it in Spanish. And my class, I'd have like 80 students. I'd have more students in my class than every other class on campus combined, CTE. You know why? Because what I would do is I would teach this stuff in English, and then I'd pay Rudy, I don't know, 10 bucks, 20 bucks, whatever. It was a good hourly rate for him. And he would teach this stuff in Spanish. And it's like the freaking students were mastering this hardcore. I mean, people that, had graduated 3rd grade were freaking good at this because they were getting it in both languages, right? Rudy, you there yet?
That they learned in English, they could then learn in their native tongue, so it made it more relatable for them.
And what we did was we established, look, if you want to talk in Spanish, fine, as long as you're talking about the subject matter, this is the, and as a result, the students were making progress because we were actually teaching the certification thing where they had to pass this class to keep their licenses, so their right to be electricians. So it was great. It was freaking awesome. Rudy, we made such a good team down there. It was a great experience, but I had to come back to auto because it's like I don't want to start. It was nice to have a mid-career break, but no, I don't want to start at the bottom of another industry. I got too much invested in automotive.
Wait a second. I'm tripping. So Rudy knows how to speak Spanish?
What?
Rudy speaks Spanish?
Rudy.
Sí, puedo hablar español con los mexicanos.
He said he was teaching in Spanish?
Funny.
Oh, Rudy's Spanish is awesome.
Español.
Rudy, if your connection wasn't so bad, we'd hear you. There are very few people that speak better Spanish than Rudy, except Rudy's Spanish is freaking street Spanish. Mine's Castilian, but his is street.
Rudy,
His Spanish is awesome.
Spanish.
¿Qué pasó? ¿Cómo están?
You
Feliz
bet,
noche
Muy
nuevo.
bien, gracias. Okay.
Okay, you guys' internet connections suck. That means chupa. Tus conexiones chupan.
Let me see if I can fix that.
It's contagious.
All
right.
Bien.
So Here's the thing. In a parallel circuit, voltage is equal everywhere. Now, do you remember the series circuit? Good, timing is perfect. I told you it's two sides of the same coin, right? Remember the series circuit? Current is the same everywhere. In parallel circuit, voltage is the same everywhere. 1, 2.
¿Cómo está esta conexión?
Nope, still bad. Current is
Yeah,
additive.
muy mal.
Right? I add the current going through this to the current going through that, right? If 3 Sanchos came in this window, 3 Sanchos came in this window, how many Sanchos were there on the street? 6. How many went running down the alleyway? 6. Now that, Gabe, is how you figure out what wire size you need. Because now you know how much current's flowing through the wire. Multiply it by 125% down the road. Yes,
Is that
sir.
better?
A little bit.
And I'm using my phone as a spot.
What's the third thing, Rudy? It's been so long since I taught this, I forgot what it was. Oh, yeah. I remember. Total resistance is always lower than any individual resistance. You know it is great. You know it is great. You know, this 13-hour day, I get so anxious about it. I mean, on Mondays, I get anxious about Thursday. But the good thing is about 8 o'clock, 8:30, it's like I feel like I'm about to get released from prison. And it feels like I'm going to be paroled. I mean, I love being with you guys and everything, but the 13-hour day, I'm more anxious about it than it is bad. You know, I worry about that I'm going to feel bad. Isn't that weird? He's crazy. Okay, look. The resistance of this bulb is 4 ohms. The resistance of this bulb is 4 ohms, but look at the total resistance. It's 2 ohms.
Yep.
So, you want to see some formulas? Let's try this. R1 times R2 over R1 plus R2. That's only if you have 2 resistances. That gives you a formula to make it easy for you. Now, I've got some interesting, what numbers do you use? 4 and 6, 24 over 10, no, 8 and 4, 12, 32 over 12. 4 and 2, 8 over 6. No, 3, 6 and 3, 18 over 9. Yeah, that'll work. Okay, let's go. You got that? Yeah, I've got about 20 minutes, so let's boogie. So I got this bulb here, which has 3 ohms. I got this bulb here that's got 6 ohms. So now one of these bulbs is going to be brighter than the other. That's all right. It's all right. And I'm not including the fuse or the switch because it's extraneous to what we're trying to accomplish here, right? We're going to try to make this as simple a circuit as we can.
A simple circuit.
Yep. There we go. I got 12 volts DC here. P, E, I, R, sub T, sub T, sub T, sub T. P, E, I, R, 1, 1, 1, 1. And as I say, do yourself a favor and make the numbers easy to calculate, you know, divisible by 12. So that would be 3 6s and 1s, 3 6s, 2s, 4s, and 1s. Don't beat your brains out with the math, right? We want to make the math easy. You're going to see the math is very easy on this. We want to make the math easy so we can focus on the actual operation. Hey, you know what I do when I get nervous? I freaking eat. That's how I got so fat. I'm a wreck, man. I'll have to find some place to put the scan tool. You done yet? Let's go, let's go.
My new house will work.
Oh, what's up with that? When's the party?
Hopefully we're closing next week.
There you go. Good, congratulations.
Okay.
Well, your internet actually sounds better. Vadim, you got it?
I got it.
Are you gonna teach it in Yiddish now, or?
I can do in Hebrew.
Oh wait, I thought Hebrew was.
Yiddish is my grandparents speak it, but Yiddish is like I don't speak it. I speak Hebrew because I grew up in Israel. Yiddish is more like when Jews live in a foreign country, this is what they would speak. But I grew up in Israel, so I speak Hebrew.
I thought Hebrew was the written language and Yiddish was the spoken language.
Yeah, but in Israel we speak Hebrew. Yiddish is only the really religious people speak.
Yeah, like Germans speak Yiddish, right?
Yeah, well, Yiddish it is a German language. From the
Really?
from the 16th century, yeah.
Well, see, finally I learned something in this class. That's what Gabe's saying under his breath. All right, so we got 12 volts DC here, and since it's a parallel circuit and the voltage is the same everywhere, we can just put 12 volts DC all the way across, right?
Mm-hmm.
Okay, we got 6 ohms of resistance here. We got 3 ohms of resistance here. 3 times what is 12?
4.
Yep. 4 times 12 is?
48.
Yep. 6 times what is 12?
2.
2 times 12 is?
24.
Man, did I ever tell you this wonderful teacher I had once that taught me how to do parallel circuits like that in like 20 minutes? Man, I'm a lucky guy. Okay, so if
his name is Rudy Kaufman.
Quack. If this cop ate 24 donuts and this cop ate 48 donuts, how many donuts total got eaten?
72.
72. 72 divided by 12 is?
6.
6. And 12 divided by 6 is?
2.
2. Yep. Now we can check our work. 2 Sanchos went down this, went in this window. 4 Sanchos went in this window. How many Sanchos came down the street?
6.
6, yeah. So there's 6 amps from here to here. There's 6 amps from here to here. And there's 2 amps from here to there. Did you catch that, Gabe? It's an important distinction. That's why you can mess around with wire size. Usually people don't mess around with wire size, but you could. Okay, so look. This resistance is 6, this resistance is 3, but the total resistance is 2. So sure enough, total resistance is less than any individual resistance. This thing right here, incidentally, is called a
Used
branch.
to say the total resistance will always be lower than the smallest resistance.
Yeah.
Yeah. This is one branch, that's another branch, right? So branch circuits, you heard all this, Gabe? This applies just as much to a house or a factory or as it does to a car.
Or like I used to say in español, el resistencia total es menos de el resistencia más bajo.
Ay, güey.
Right? Okay. So the 3 rules of the parallel circuit are Voltage is the
Just
same.
because I'm white don't mean nothing.
Yeah, that's what you think. What did Rudy say? If I go to jail, I'm claiming PISA. That's it.
That's exactly what I did.
I don't think I'm going to tell you what Rudy said in King Taco, which was the funniest thing I ever heard. No, I don't. Well, I don't know.
How do you know about prison cars, Mr. Rowcliffe?
Not on recording.
Yeah, right. Besides, I mean, people might take it wrong, but it was the funniest thing I ever heard. But yeah, because I was a freaking idiot, Gabe. I was a terrible person. I was a horrible, horrible person. And just I had one fingernail outside the cell when I finally realized this is permanent. You know, there ain't no coming back. There you might be coming back part way from this, but you can't come back. You better get the hell out of here before that door slams shut. Got lucky hard. I had one eye open and I saw where the sun was shining. Got lucky. That's all I can say is luck. Okay, now I'm going to try a little more sophisticated circuit just because I can. And I think it's funny. I'm going to come over here like this and go all the way over here. This is going to take a while to draw, but 50% longer. I'll bet you'll be able to figure it out by yourself though. All right, so what is this? 8 ohms, 8 ohms, 8 ohms. There you go. 12 volts DC. It is currently 847. I'll give you till 850. PEIR. Probably take you that long to draw it. So anyway, no, I was going to tell you where I went to eat for dinner, and it was a very poor choice. Maybe because I try to eat too fast. Actually, this will go really fast once you have it drawn out, because all 3 branches are the same. Next 2 Mondays are holidays, folks.
Really?
Yes, sir.
Hey, Rowcliffe,
Hi.
I need to pick your brain real quick.
Okay.
I want to make sure my math is going the right way. It's on this sort of, but not. It's if you have 3 12-volt batteries that are 100 amp hours apiece. No, 6 12-volt batteries, each 100 amp hours.
Yes.
And you put 3 of them in series, the other 3 in series, and then put those in parallel. You still end up with 300 amp hours.
Yeah.
Okay.
300 amp hours at 24 volts, right?
No, at 36 volts.
3 of the, okay, wait.
12-volt
3 of the
batteries.
series.
Put
300
in series.
Okay, put them in series. So now you got 36 volts. No, you'd only get 200 amp hours.
Out of each bank.
Right.
But then
No,
you put
no.
those 2 banks in parallel. Wouldn't that up the amp hours?
Yeah, if you put them in, whatever's in parallel ups the amp hours. Whatever you put in series, the amp hours remain the same.
Okay, so there'd be 100 amp hours and 100 amp hours. Put them in series, it'd be 200 amp hours.
Put those in parallel, it'll be 200 amp hours.
Yeah, okay.
Yeah.
Because I'm thinking about converting my golf cart that's 36 volts from 6-volt batteries to 12-volt batteries.
Mm-hmm.
And it has 6 batteries in it right now.
6.
And I want to keep the 6 batteries.
Right.
But I want to go to 12-volt batteries.
Right.
So I want to take one side and make it series, make the other side series, and then put them in parallel.
Mm-hmm. Yeah.
So that way the cart only sees 36 volts, but double the amp hours, so I can get more runtime
Sure.
out of it.
That's a great idea. Plus 12-volt battery is much easier to get. Much cheaper.
Yeah,
too,
well, not in the golf cart world. 6 volts are easy to find.
are they? Okay. All right. So where are we at? 12 volts DC, run it all the way across because you know it's a simple parallel circuit. So that they're all 12 volts. Okay, you got the 8 ohms. You got the 8 ohms, you got the 8 ohms. So once you have once you have 2 of any column, just run it. 8 times what is 12? Oh, well, that's not
1.5 amps.
1.5 amps. They're all the same. Sorry about the numbers. I didn't mean to do that, but it doesn't really matter. 1.5 times 12 is how much?
18 watts.
How do you know? What's up with that, Mr. Burks? What's going on here? What's the meaning of this madness? Okay, 18 plus 18 plus 18 is?
54.
Oh, you're not going to like this, though. 54 watts. How about 1.5 plus 1.5 plus 1.5?
4.5.
Right? 4.5 amps. Now, what 12 divided by 4.5 is, I'm not sure, but it's going to be
2.67.
2.6. Yeah, 2. Uh-oh.
2.67. Yeah.
2.67. Yeah. Ohms.
Around.
How'd you know that? I didn't even teach you how to do that. Now, this will go on. I mean, you could add 6 more lights, right? But what's going to happen to the total resistance as you add more lights?
Gonna go down.
Keeps going down. What happens to the current flow as you add more lights? Keeps going up. So eventually, if you keep adding lights, what's going to happen? You're going to pop your fuse.
Unless you keep increasing the fuse.
Well, no, because the fuse is there to protect the circuit. So you would have to increase the wire size as well.
Yeah. If you were building the circuit, adding more, this is how you could keep adding until you figured out the maximum number of lights.
The reason that Rudy knows about this issue is because jackasses that don't understand what they're doing, they keep adding speakers in parallel to their car stereo. And as they keep adding more and more speakers in parallel, the resistance keeps going down and down and down. So the current flow keeps going up and up and up, and eventually it just blows up the power transistor. True story?
Yep.
Yep.
It blows your amp out.
So what we used to do back in the guitar playing days is when we were using 4 cabinets, you couldn't put them all in parallel. You would put 2 in series with each other and then put those in parallel. And that would give you the 8 ohm impedance you needed instead of going down to like 1 ohm or 2 ohms and blowing up your amp. Yeah, because if you understand how to do this.
In automotive, you want to keep it so that your amp is the happiest at its middle ground.
Right.
For example, my Ford Flex has 2 subwoofers that have dual voice coils. So it's like I have 4 subwoofers. They are wired in a way that my amp thinks it's pushing 1 subwoofer.
Right, exactly. Yeah, series and parallel, which is what we'll go into next time.
Which is what I was talking about with the batteries with Rocliffe while y'all were figuring this out.
Yeah, exactly. Because what we're going to do is we're going to go into different combinations of series and parallel, at least in speakers, because it's got to stay with either 4 ohms, 4 ohms, 8 ohms, 16 amps.
No,
and it's not going to be, an amp is not going to be happy if you give it the wrong impedance. That it's not.
And car amplifiers like 2 ohms or 4 ohms. That's it.
That's because that way you can
below that, you start burning stuff up in the amps.
Right.
You get up too high, you'll burn stuff up in the amps.
Will you, or just be quiet? Because impedance is resistance.
And I have
be quiet.
I have worked on a car that had 10 subwoofers on 2 amplifiers.
But how did they wire it though?
Combo.
Yeah.
Series and parallel and multiple series and parallel connections.
Okay.
And then they put the amps in series too.
Really?
Yeah. It was wicked the way that amp setup was done.
We only got 5 minutes, so let's do an analysis of how much current flow we have at different points in the circuit, because this is important.
Yeah.
We know that there's only 1.5 amps right here, and there's 1.5 amps right here. because the only current flow here is feeding this load. But right here, you've got to feed this load and this load.
Yeah.
So there's only 1.5 amps here, and there's 1.5 amps here. But on this wire, you've got 3 amps.
amps.
And you've only got 1.5 amps here, and you've only got 1.5 amps here. But right here, you've got
4.5.
Yeah. Good. Wow. Got lucky because sometimes people struggle with this. But that's how you do wire sizing, Gabe. You got to understand the circuit well enough to understand what the current flow is in different parts of the circuit. This is especially helpful when you've got like multiple motors in a circuit, because wires is so expensive, right? So you need to understand how much current flow you have, you know, motor 1, motor 2, motor 3. It's the exact same thing, except you would do it by watts or amps. You want, okay, Gabe, let's do one for Gabe, just for fun. If you guys want, I'll show you how to do it, and it's useful. Let's do it with 240 volts just for fun, just because we like Gabe so much. Okay, I'm coming in here. This motor draws what?
Can't see the top of the page.
Yeah.
Okay, that motor draws 40 amps. This motor draws 40 amps. This motor draws 40 amps. Okay. Salvale. See, Gabe, I told you your friends need to be here.
I already told him he's lagging. So
Well, yep. Well, stay broke, right? That's all you can do.
Yeah.
I mean, it's wonderful to have a friend to where you can go on the journey of learning and promotion together. But if
I
friend,
think he should just learn from me when we're driving to the job site, and I tell him, "Oh, this is what I learned in class yesterday." Oh, really?
well, why don't you watch the? I mean, the videos
tell
are on
him.
YouTube for a
I
reason.
told him, the videos are on YouTube. Oh, really? He's like, yeah, all right.
Yep. So 2, 2, 2, 2.
Bro, next time you're driving to a job site, ask to borrow his phone, look up it on his YouTube, and subscribe to it.
For him,
And
huh?
turn on the bell notifications.
Yeah, just
Drive him nuts and pop up every time he posts a new video. And he'll have to watch it.
Here's an important thing that you need to understand, folks, because this is industrial motor stuff. And we have to, I mean, we're talking about big wires. All right, so we know that we got 240 volts at each motor, right? Mr. Burks, you know how to do this without me teaching you?
We'll start at 3. The resistance is 40 amps. I mean 40 ohms.
Really?
Since we know the volts is 240, so we got 6 amps power in that.
No way, because I've got 40 amps here. I got 40 amps here, and I got 40 amps here. So total power consumption is going to be 120 amps. Right.
Oh, so you're doing okay. I was
Current is
still on
additive. Yeah, I'm sorry, because this is amps now, not ohms. So that's 120 amps. So what's my total resistance? 240 divided by 120 is
2
ohms. Okay. What's the resistance of each individual motor? 240 divided by 40?
Yeah.
240 divided by 40?
8.
What?
6.
240.
6.
6. I mean, wait a minute. Yeah, 6.
The hell?
Yeah, it's all delayed.
Yeah. All right. What's 40 times 240? 960? No, 9,600.
9,600.
Yeah, 9,600. Or 9.6 kW. Is that correct? Yeah, 9.6 kW. K is 1,000, right?
A kilowatt.
9.6
Yep.
kW. All right, what's 9.6 times 3?
28,800.
28.8 kW. Okay, wire is sized based on ampacity, right? So let's make sure we understand how many amps there are in every part of the circuit. Right here, we got 40 amps. Right here, we got 40 amps. Incidentally, can I ask you, how come there's no dotted line on the bottom wire?
Because you're talking about AC current, not DC.
Yeah.
Because I'm talking about alternating current. Excellent, good, okay. Now, I've got 40 amps here, that's true. And I got 40 amps here, that's true. But how many amps are there in this section right here?
80.
80, right? Because it's got to carry the 40 to this one, and it's also got to carry the 40 to this one. So there's 80 amps here, 80 amps there, which means I just went from like a number 8 wire to like a number 4, if I remember correctly. Look it up, table 310.16, I believe. Yeah.
I can't. My book's in storage.
Current carrying capacity, no more than 3 current conductors and raceway cable or conduit. Love it.
I can't. My book's in storage.
Right. Well, it is on the internet, but it doesn't matter. Wait, oh, I got to be careful about that. I got 40 amps here, and I've also got 40 amps right here. But how much current is on this wire right here?
120.
120, because it's got to supply 40 here, and 40 here. Yep. And that, my friends, is like a number 1 or a double lot, maybe? No, single lot?
Maybe a double lot. I think if I remember correctly, at 120 amps, if it's a short run, you can get away with a 1. If it's anything over, right? If it's anything over 5 feet, I think you have to go to a double lot.
Yeah. Good, Rudy, because Rudy remembers when it comes to wiring size, you got to start thinking about how long the wire is, how hot the wire's going to be, how hot the environment the wire's going to live in is. Good, yeah. See, that's the thing. I mean, that's the thing, Gabe. This is why some people are laborers and some people are electricians, right? Because this is the thing that makes you money. This is the thing that makes you money, not these. I mean, a monkey can do wiring, not very well, but a monkey can.
Who's the electrician?
Me.
I'm sorry. When I say a monkey can do wiring, I also believe a monkey can do brake jobs. So I'm not disparaging your craft. Now,
call me after class, please.
I'm not saying they do it well, and I'm not saying they know what they're doing, but I mean, I can teach someone to wire receptacles real quick. I mean, chances are good they'll do it wrong, but.
Can you teach the guys who wired my new house then?
Okay, so here we go. And you can make up problems like this for yourself all day long. I strongly suggest it. Get yourself a calculator so you don't freak yourself out. But get yourself to the point where you can do this stuff as quick as me or Rudy. Because a simple parallel circuit.
Well, that's on that's on the Uglies book too, isn't it?
I don't know.
Oh, you don't.
I never opened it.
Oh, okay. The Uglies book has all these little formulas right here.
Right, but this is a much easier way to do it because, at least for me, I used to be really, really effective at getting meaning and understanding from reading. But since I got out of the habit, it's like playing tennis. I'm no good at it anymore, or golf, right? It's something you have to practice. And I hardly read anymore.
And you have to keep practicing.
Right. So, I mean, it's like spelling. I used to be great at spelling because I read so much. Now I'm
Jim Nutt in golf.
Yeah. Okay, so this is how you do it. And that's a simple parallel circuit, and that's how almost everything is wired. That's how your Christmas tree lights are wired. That's why when you keep adding more and more Christmas tree lights, eventually it blows the circuit because the current flow just keeps going up and up and up. That's also why when you have the lights on in your old house in your bathroom, and then you plug in a hair dryer, eventually the current flow goes so high that it pops your breaker. Well, what's the only thing that makes the current flow high in a 120 volt circuit? The resistance going low. And that
lower resistance.
Yeah, the more loads you put on a circuit, the lower the resistance is going to be because they're going on in parallel. Yeah. Now, we're gonna find that when you add loads in series, the current flow goes down. But that's for next week. So what we're gonna do next week is we're gonna do series circuits. I'm amazed you guys picked this up this fast. Anna, you doing okay? She didn't say anything, so. I don't
No,
know.
I'm fine. Yeah,
Okay, all right.
sorry. Michelle just answered, she had a migraine today, so anyway,
Sorry to hear that.
yeah.
So next time we're gonna go over simple series circuits, then we'll do a little bit of series. I don't know if we'll do series parallel. Yeah, a little bit, but really it ends up looking like this. Let me ask you a question. If I was to have a switch that controlled this motor, how many amps would it have to be able to carry?
Hundred and 20.
20, yeah.
Nope.
120.
A
Two
switch,
Not
hundred.
carrying all of them?
no, a switch that controls only this motor. What's it have to be rated at?
40
Oh,
amp.
40 amps?
Amps.
40.
Because we have a simple series circuit from here to here, right?
Mhm.
We have a simple series circuit from here to here where there's only one path for current to flow. So
Mhm.
what would the switch that controls this motor have to be rated at?
40?
40.
Or the fuse? Yeah, 40.
Yeah.
What would the fuse for this motor have to be rated at?
40.
40.
Okay, but what would the fuse here have to be rated at?
120.
120, yeah.
120.
Great, fantastic, great job. Yeah, yep. And that's how you do it.
My electrician buddy, call me after class.
I don't got your number.
I'll put it in chat.
Okay.
It's 1-800 fake homie.
Don't start that crap again.
Alrighty, everybody loves you. It's the opposite of me. Hello. What do you think? Questions, comments, thoughts on that? What do you want to study next? Because we're coming out of theory and we're going back into systems. So which system would you like to study first? Incidentally, this is the 5th week, which means we got 15 weeks left. That's it. So we got to budget our time.
So is there any chance we're gonna get back in?
Oh yeah, absolutely. Like I said, I think what's going to happen is a month before
think we will?
recall, they're going to open up the schools and say, "Oh, look, aren't I a hero? I saved the day." Because I got to tell you, all the kids that were supposed to learn to read this year didn't work. All the special ed kids that needed specialized instruction didn't get it. This is horrifying, horrible, horrible, unbelievably horrible. All the kids that were supposed to learn to count, you know, especially read. I mean, reading is something
Yeah.
Essential.
not most
Okay,
parents are not
so
well
stop
equipped to teach. Pardon?
Look, and I'm gonna say this as a parent with the special like education need. He's struggling, so
Yeah,
it didn't work.
they're all struggling. The best of students are struggling. You ready? You ready, Vadim? This is
Yeah.
okay. Here's the thing. If the students aren't in school, how are they going to learn to hate America?
Right? That's true. I agree about this, because look, I went through colleges and universities, and all the professors are so like one-sided, many of them,
Yeah.
because they never had a real life experience, those people. All they have been is all their life in academia, many of them.
Yeah. Well, that's the clique they run in.
You see, I love America because I know other countries how they are, and my parents were born in the Soviet Union, and I know stories about it, and I know how they are. So there's nothing better than capitalism, in my opinion, man.
Right. Yeah, read the Gulag Archipelago.
And
The
it's
freest people made the
unfortunate-
biggest economy.
And
that's
it's
how I see
unfortunate
it.
that people don't hear what you're saying, though.
I do public
People
speaking
don't get
sometimes
it.
in many clubs.
I'll tell
And
you.
that is so good. And I wish more people would hear it, but they don't. You know what? They hear it, but they don't want to hear it. I think, but that's
They had
what
it
you
too.
do.
They
That.
don't know nothing what's going on anywhere.
I was supposed to be a professor of education. That's what I was training to be, as a professor of education. I have all the training. I just didn't finish. Can you imagine me in the School of Education? So I actually counted as dodging a bullet. But we don't want to express any
Oh.
political views because after all, this will probably all be analyzed later and we'll all lose our jobs because of it. So anyways, my point was,
Mm-hmm.
Rudy, you
Stop
look
the
like
You'll be
recording.
retired then.
you look like Colonel Kurtz in Apocalypse Now. Quack. Okay,
Stop the recording.
Stop the recording. That's it. Come on now.
I guess. All right.